But the note packet looks like this. All right. You see it says 5 on notes, and we're dealing with operations with polynomials. Okay. So what we're going to do essentially is work with addition, subtraction, multiplication, division of expressions that involve variables. All right. And we're going to have to go through a list of properties and how they relate to polynomials. So the first thing we're going to talk about is what's called the product of powers. So if we have, and as we're going through this, anytime that you see A and B, these are kind of more the generic definition of what our property is. And then we'll show an actual example off to the right when we involve real numbers. But if you ever see an A and a B, those are just, numbers. So any number that you can choose. And then obviously the X's are variables, right? Or if you see a Y, that's a variable as well. When we're dealing with product of powers, so if we have X raised to a number times X raised to a different number, okay? What we do in that situation is we add the exponents, okay? So as an example, say you had 3 squared times 3 to the 4th. You can do 3 squared, and that's 9, and then you do 3 to the 4th, and that's 81, and then multiply those numbers together. Or you could just do 3 to the 2 plus 4, which is 3 to the 6th. So it's all the same thing. This is just ways for us to simplify these expressions. So when we have the same variable, different exponents, we add the exponents together. Okay. When we are dividing, we do the opposite. So when we're multiplying, we add. When we're dividing, we can think of this as x to the a minus b. So we have x raised to a power divided by x raised to a different power. We're going to subtract those powers from each other. So say it's x cubed over x squared. We could think of this as x to the 3 minus 2, or just x to the first power, right? Because 3 minus 2 gives me 1, so that just becomes x. Okay. Any questions about the first two properties? So when I multiply, same variable, different exponent, I add. When I divide, same variable, different exponent, I subtract. Negative exponents. This is going to be useful for us to understand. It's x to the negative a. This is the same thing as 1 over x to the positive a. So if you see a negative exponent, you want to rewrite it as a fraction so you have positive exponent. But all you're going to do is kind of take that and flip it. Think of this as x to the negative a over 1. You flip the fraction and you change that negative number into a positive number in the denominator. Same thing over here. Instead of 1 over x to a negative variable or a negative number, you can think of this as x to the positive a. So you're going to flip the fraction and change the sign. Okay. So like if this was 3 to the negative 5, that's the same thing as 1 over 3 to the positive 5. Or if it started off as 1 over 3 to the negative 5, this becomes 3 to the positive 5. So you just flip the fraction, change the sign. Okay. Any questions about negative exponents? That one's going to be useful for us later on when we start to use division to simplify. So just kind of keep that in mind. If we have an exponent, or excuse me, a variable with an exponent, and then it's raised to another number, this is when we multiply those two numbers together. So you have x raised to a number, and then that whole quantity raised to another number, you multiply the two together. That's a way for us to simplify. So say it's like 3 squared raised to the 3rd power. Well, we can think of that as 9 to the 3rd power, or you can think of this as 3 raised to the 2 times 3, which is 3 to the 6th power. So you see a power of a power, you multiply those numbers together. Any questions there? If you have a product of 2 variables and then that whole quantity is raised to just one variable, or excuse me, one number, you could do the product first and then raise it to that power, or you can do the power of each and then find the product. So as an example, you might have 2 times 4 raised to the 3rd power. Well, that would be 8 raised to the 3rd power. Or you can do, so this is equal to 2 to the 3rd power times 4 to the 3rd power. And it's going to give you the same value either way that you do that. But it's just a way for us to simplify. That works the same with division. So if you have a number or variable divided by another variable, all raised to a certain power, you can think of this as x to the a over y to the a. So instead of doing the division first and then raising it to a power, you can raise each of those numbers to a power and then do the division, excuse me. If it's raised to a negative a, what do you think we have to do? How do you think that might change it? And if you think back to negative exponents, remember we said we kind of have to flip and we then change the sign. So what would the flipped fraction of x over y be?
Y over x.
Y over x. And then we change the sign to a positive a. So then we can think of this as y over x over a. Okay. An example here, say we have x over y quantity squared. Well, that just becomes x squared over y squared, right? You either divide first and then raise it to a power, or you take it and raise it to a power, then divide. Okay. Any questions about power of a product or power of a quotient? The very last one, 0 power, anything raised to 0 is just 1. So if you have any number raised to 0, it's just 1. One thing to keep in mind though, say there's a negative maybe on the outside. Well, then that's going to become -1 times 1, which is now -1. So the only time that this changes is if there's a negative, excuse me, on the outside of your x to the 0. But everything raised to the 0 power is just 1. Any questions about any of these properties? So when we have a product of the same variable, we add the exponents, quotient, subtract, negative, flip the sign and flip the fraction, power raised to a power, multiply, quantity raised to a power, you can do each of those individually raised to that power, then multiply each of those individually raised to that power, then divide, and then anything to the 0 power is just 1. Okay. Any questions so far? All right. We want to be able to use these properties to help us simplify some polynomial expressions. Okay. So the first thing we're going to look at is addition and subtraction. So we might have multiple terms here within one polynomial expression, and we're going to add or subtract that to a different polynomial expression. First, we need to decide what operation we're using. So are we doing addition or subtraction? If we're doing subtraction, very similar to what we did with imaginary numbers, or excuse me, complex numbers. Remember, we had to distribute the negative before we could combine like terms. The same thing goes here. And the only thing that we can combine, and the biggest, that's why it's in capital letters there, is a variable if they have the same power. So you can only you can only combine x squareds with x squareds, xy's with xy's if you have multiple variables. We'll see a couple examples of where that applies, okay? I'll go through this first example kind of on my own with these steps, and then we'll do a couple examples down towards the bottom as a class, all right? I have 8a squared plus 8a minus 3a cubed minus a to the fourth minus 4a squared plus 3a cubed, all right? The first term there isn't going to change at all. I'll still have 8a squared plus 8a minus 3a cubed. But now I notice I have subtraction as my operation. So I need to distribute that negative to each term. And what that's going to do is change the sign of each term. So now I'm going to have minus a to the fourth. Instead of negative 4a squared, it'll be plus 4a squared. And instead of plus 3a cubed, it's going to become minus 3a cubed. Okay. So just distributing the negative. Now what I want to do is try and combine terms, but I'm going to go from highest exponent that I see down to the lowest exponent that I see, right? So they all have an a there. That's my variable. The highest exponent I have is a to the fourth. There's no other a to the fourth term, so I'm going to write that first. And what I would get in the habit of doing is after you use a term, just cross it off, right? So you don't have to worry about combining it with anything else, or if you used it already, you're not rewriting it twice. You have negative a to the fourth. Then I'm going to go to my a cubed terms. Well, notice that I have a negative 3a cubed minus another 3a cubed. I can only combine the terms that have the same exponent. So I have negative 3a cubed minus 3a cubed. That's going to give me negative 6a cubed. Right? I'm just adding and subtracting. I'm not multiplying at all, so I don't have to add exponents. I go to my next highest variable, which is a squared. I have 8a squared plus 4a squared. That's going to give me positive 12a squared. And the only term left over is this positive 8a. Notice that I'm writing my answer in descending order. So I start with the a to the fourth, then I go a cubed, a squared, a. Get in the habit of doing that. So writing your answers from highest exponent to lowest exponent, and kind of just working from there. Does anybody have any questions about that first example? Okay. Example 2, you're doing addition. It's very similar to the first one, except you don't have to distribute, so you can just drop the parentheses and combine like terms. We're going to go through the bottom 3 examples where we have to do some distribution and kind of use more of the properties that we talked about on the first page to help us simplify. Notice that I have a 4 and a negative 3 in front of each of those terms there. I'm going to start by distributing into those terms. So I'll distribute the 4 to each of these terms. And what happens to my expression now? What happens when I distribute that 4? What are each of those terms going to become? If I just distribute the 4, what would the next line be?
Four a squared plus 20a minus 24.
Good. 4a squared plus 20a minus 24. When you're distributing multiple times, just take it step by step. So do all the distribution first. Another thing we need to notice is we have a negative sign here. So we're doing subtraction between each of those terms. I'm going to distribute the negative 3, right? Don't worry about distributing a positive 3 and then multiplying everything through by negative 1 again. Just go ahead and distribute the negative 3. So when I do that, I'll have negative 3 times 2a cubed, which is negative 6a cubed. Negative 3 times positive 4a gives me negative 12a. Negative 3 times negative 5 gives me positive 15. Okay. So not only have I distributed that coefficient term, that 3, but I've also distributed the negative with it. So I did 2 steps at once, essentially. Okay. Now I'll go through and combine like terms. What's the highest exponent that I see here?
3.
Right. So the exponent's 3, and it's the negative 6a cubed. And I can't combine anything with that, right? So I've used that term. I go to my next highest exponent, the a squared. Can't combine anything there either. So now I'll go to 20a, and I'll see, can I combine anything with the 20a? Right, the 20a minus the 12a. And that gives me 8a. Okay. Then I use each of those terms. Then I do negative 24 plus 15. That's going to give me negative 9. I can't combine anything further, right? I can only combine what has the same exponent value. So that's my final answer. Any questions there? Let's take a look at the next example. I'm going to distribute, but now instead of distributing a number, I'm distributing a number times a variable. It's all the same steps, right? It works the same way. I'll still distribute that 5x to each term. But now we have to remember some of the properties from before, right? If I'm multiplying and I have the same variable, I'm going to add the powers together. Okay. So 5x times 2x squared. I'll multiply the coefficients normally. That's going to give me 10. X times x squared, I'm going to add the exponents. So that's x to the first times x squared. 1 plus 3 is going to give me an x cubed. Okay. And we've seen that before, right? When we have to add those exponents together. I'll do 5x times negative 3x. What do you think that's going to give me? So it's x times x. It's x to the first times x to the first. So I'm adding those together. It wouldn't be squared, right? 5x times 4, there is no x value that I have to worry about adding or anything like that. So the x just tags along, and I multiply the coefficients normally. Anybody have any questions up until this point? I'll do the same thing in the second term. I'm distributing a 2x to the 7x and the negative 8. Well, what's 2x times 7x going to give me?
(14x squared).
14x squared, right? I'm adding those exponents. 2x times negative 8, negative 16x. I look to combine like terms. I'll have 10x cubed, right? Because there's no other x cubed term. Negative 15x squared. Can I combine anything with that?
You can combine it with the 14x squared.
14x squared, and now I have negative x squared, right? And then the 20x and the negative 16x, that's going to give me a positive 4x. And that expression there is going to be your final answer. Okay. Any questions about that example? So now we're seeing some of those properties that we talked about on the first page in real time. All right. Let's take a look at the final example down there at the bottom, and then we'll move on to multiplication. So I have 5xy times 2x minus y plus 6y squared times x squared plus x. Well, now I have multiple variables involved. We still need to follow our steps from above. I can only combine things that have the same variables and the same powers, right? So I'll kind of do this one on my own as well for the first half, and then we'll work on the second half together. I'm still going to distribute the 5xy into each of those terms. But when I do that, I'll multiply the coefficients, and then I'll take it variable by variable. I see that they both share an x. Well, x times x is going to give me x squared. There is no y term that I can combine, so the y just tags along. So 5xy times 2x is going to give me 10x squared y. In the second term, 5xy times negative y, well, 5 times negative 1 is going to give me negative 5. There is no x term to combine in this case, so the x tags along. And then y times y is going to give me y squared. Okay. Any questions there so far about how that works? So if you can't combine terms, like if there is no y to multiply by a y, you just write it as is. If I take a look at the second distribution, so 6y squared times the x squared times the 6, what's that going to become when I distribute the 6y squared into that binomial? Is there anything for me to combine?
No.
No, right? So I just leave it as is, 6x squared y squared. Make sure that you write it in alphabetical order too. The x's always come before the y's. And then what's 6y squared times positive 6?
36y squared.
36y squared. So you're multiplying. So I think you were adding. That's okay. But it's going to be 36y squared. When you have multiple variables, right, and you're combining like terms, they have to have the same amount of variables and the same exponent too. So I have x squared y. There's no other term here that also has an x squared y. I have xy squared. There's no other term that has an xy squared. So this is actually going to end up being your final answer here. The only time you can combine is if they have the same variable and the same exponent as well. All right, so xy with xy, x cubed y squared with x cubed y squared. Any questions about addition or subtraction? The biggest thing is to make sure you take it step by step. Don't try to do too much at once. Everybody good? All right. We'll move on to multiplying and dividing. We kind of just did a lot of multiplying in the last example, so we're only going to do 2 examples here because we could multiply the same way we did when it's just one term times a term. We got to make sure we add the exponents and all that stuff. You could also see examples where you have a 2-term polynomial times a 3-term polynomial. And we'll walk through that example in a second. We're going to do these 2 middle examples here. When we're multiplying, right, let's take a look at our steps. Multiply the coefficients normally like we did. Multiply the variables that are the same and add the exponents, right? If they're not the same, you kind of just combine them. And then you want to combine like terms if possible. So if I take a look at this second example, just take it term by term. When I multiply the coefficients, what's 5 times 4 going to give me?
20.
20. X cubed times x, what's that going to give me?
X to the 4th power.
X to the 4th, right? Because we're just adding exponents. Y to the 5th times y cubed, what's that going to give me?
Y to the 8th.
Y to the 8th. Okay. Go through your steps. Multiply coefficients. 5 times 4 gives me 20. Multiply your variables. They have to be the same. So x and x, that's going to give me x to the fourth, or x cubed and x to the fourth, y to the fifth, y to the third, y to the eighth. You just combine them all together, and I can't simplify any further. Okay. Any questions about that example? You might see examples on your homework tonight where you're multiplying and you have 2 terms times 3 terms. Well, this is the first time we're seeing this, so I'm going to do this kind of on my own. We'll take it step by step. All you're going to do is take 1 term from your 2-term polynomial there, or your binomial, and distribute through to each term here. All right. So I'll take x, I'll multiply it by each of these terms. What's x times x squared going to give me?
X cubed.
X cubed. X times 2xy. Well, the 2 will stay the same, right? I have an x times an x, that becomes an x squared. There is no y term, so that just tags along, and I have 2x squared y. X times a y squared, when we're multiplying, so another key part here, when we're multiplying and the variables are not the same, we just write them next to each other. We don't add exponents or anything like that. So x times y squared is just going to give you xy squared. Okay. Any questions about the first piece of distributing there? Then what I'll do is I'll distribute that second term to each of these terms here. So the negative y times each of those 3 terms. What's negative y times x squared going to give me? Are they the same variable? No, right? It's x and y. So if they're not the same variable, we just write this as negative x squared y. You can't combine anything. You can't add exponents or anything like that. So you just write it as is. 2xy times negative y. Well, that's going to be negative 1 times 2, which is going to give me negative 2. There is no x term that they both share, so I'll write the x there because it's still present in this term. What's y times y going to give me? Y squared. So 2xy times negative y, negative 2xy squared. You're just combining things that you can combine. What's y squared times negative y? Negative y, not squared, because you have squared and to the first power, so you're adding them to the third power. Good. Okay. Just take it step by step. See what they share. So x terms and x terms, y's and y's. They don't share anything. You just combine them, right? And we saw that in this first one here. X squared times negative y just becomes negative x squared y. Now what I want to do is combine any like terms, okay? Is there another x cubed term throughout here, or do I just have one x cubed term? Just one. So I'll leave that alone. I'll rewrite it. Is there another x squared y term that I might be able to combine with this term here?
Yes.
Yeah, right? I have a negative x squared y. So I have 2x squared y minus 1x squared y, which is just going to give me x squared y. Is there another xy squared term I can combine with this one?
Yes.
This term here, right? So I have 1xy squared minus 2xy squared, and I have a negative y squared. My leftover term is y cubed, and this is my final answer. So now we've seen some examples where we can distribute and we can combine terms, we can distribute and we can't combine like terms. Just be really careful about having the same variables and the same powers for each of those variables before you can combine. Okay. This is going to be the trickier problem that you see, right? You have to distribute twice. So you have to distribute each term to each of those three terms and then combine. It could get tricky. Just take it step by step. Do one term at a time. Be careful about your signs. You're adding exponents when you distribute because you're multiplying, right? But you can only add if they have the same exponent. Any questions about multiplying? All right. The last thing we're going to talk about is dividing. Dividing is just a little bit different because everything we've seen so far has been distributing and we add our exponents. When we divide, we subtract our exponents, right? And we talked about that on the first page with the quotient of powers. You see we have the same variable, we subtract. Okay. When dividing, we divide coefficients normally. So just like we multiply coefficients normally, we're going to divide them normally. When we're dividing coefficients that are the same, so say we have an x squared and an x, the exponents that have that are highest after subtracting, that's where we put the variable. So we might leave answers with a numerator and a denominator. It might not simplify to an integer like we've seen with normal dividing. All right. And we'll see that in this example here. So I don't have any coefficients, right? I don't have any numbers there. I'm just going to start by dividing the variables that I have. I can only divide x's with x's and y's with y's. Okay. Well, if I'm dividing x's, right, I'll just break this up into x squared over x to the fourth. Okay. That means that I'm subtracting exponents, right? So I have x squared, or excuse me, x to the 2 minus 4, or x to the negative 2. Well, if we think back to our property for negative exponents, remember, if we have a negative exponent, that means that it goes in the denominator as a positive exponent, right? So when I'm simplifying my answer here, I know that I'm going to have an x squared somewhere down there. Because when I divided the x values there, I got a negative 2, so that's going to go down in my denominator. Another way you can think about it is wherever the higher exponent is, so you could have just done 4 minus 2, I know that's x squared, that's going to go wherever my higher exponent is. So the x to the fourth in the denominator, I'll put the x squared in the denominator. So you don't have to worry too much about negatives or anything like that. When I look at my y terms, I have y to the fourth over y squared. What's that going to become when I do y to the fourth divided by y squared? Remember, when I divide, I subtract exponents. Right, so y to the 4 minus 2, or just y squared, right? And it's positive, and my higher exponent's in the numerator, so I'm going to write my y squared in the numerator, and this is my final answer. So that's how it simplifies. Okay. This is the trickiest part about division, is understanding where things go. It's not necessarily understanding that you have to subtract, but where should you put the variable, okay? So that'll be the toughest part for us so far, but we're gonna go through a couple more examples. Hopefully it becomes a little bit easier. The next example, I have negative 4x cubed y cubed z over 2x y z cubed. So now I'm dealing with three variables and I have coefficients. Take it variable by variable and it'll be a lot easier for you. First thing I'll do is divide coefficients. What's negative 4 divided by 2? Negative 4 divided by 2. Just negative 2, right? We're just worrying about the coefficients there. So this column here. Now I'm going to go to x cubed divided by x. What is x cubed divided by x going to give me? Remember, I'm subtracting the exponents there.
X squared.
It'll give me x squared. It's a positive x squared. My higher exponent is in my numerator. So I'm going to put the x squared in my numerator. I'll move on to my next variable. I have y cubed divided by a y. What's y cubed divided by y going to give me? Y squared. And where should I put that? In the numerator or denominator? The numerator, right? Because it's positive, but also my higher exponent is in the numerator, so I'll leave it there. Then I have z divided by z cubed. What's that going to give me?
Z. Just Z.
Not just z.
Would it be Z times or to the power of -1?
Right, z to the -2. So this is z to, you can think of this as 1 minus 3 or z to the -2. Well, if it's negative, where's that going to go? In the numerator or denominator? Denominator, right? But instead of writing it as a -2, it's going to become a +2. You can also think about that z cubed being the higher exponent, so that's going to go down there. That would be your final answer. So just take it coefficients first, then look at it variable by variable. Very quickly, I just want to kind of go through this last one on my own. It's very similar to the example we just did, but just to kind of, hopefully solidify some points that we've discussed. If I just divide coefficients, what's 12 divided by 2? 6, right? So I'll have 6. X to the 4th over x to the 5th would be x to the 4 minus 5 or x to the -1. Oh. And if it's negative, is it going to go in the numerator or denominator? Denominator, right? And it becomes just positive x. I also have y squared over y to the 5th. Well, that's y to the 2 minus 5 or y to the -3. Negative is in the denominator again. Again, higher exponents for x and y are both in the denominator, so that's where those variables should end up. My final answer is 6 over y cubed. So just go through, divide coefficients, divide each variable, ask yourself, where's the higher exponent? If it's negative, it should go in the denominator and change to a positive. If it's positive, then it should stay in the numerator, okay? Any questions about multiplication, division, addition, subtraction, or any of the properties that we discussed today with polynomials? Okay. Your homework for tonight is on page 307. You're doing 17, 19, 21, 23, and 29 through 37 odd. So all the odds. If you take a look in the folder for today, you see the page numbers are there. So you're doing some multiplication, some division, powers to powers, and then a lot more addition, subtraction on the other section as well, okay? Any questions there? The bell's about to ring. Make sure you get that assignment done, and I will see you all tomorrow. All right. Enjoy the rest of your day.